Alright, so today we are going to review finding the molar mass of elements and compounds using information that we had from the last lesson in counting atoms in a formula, as well as reviewing the concept of molar mass itself and how to use the periodic table to find that. So today we're going to use all the information that we used in the last lesson, counting atoms and chemical formulas, how to break them down, whether they're subscripts, parentheses, all those things, and then pair that up with the periodic table and the information we can find in the periodic table to find the molar mass of elements and compounds. In the next lesson, we're going to take the molar mass and convert that and revisit the concept of moles, which we'll talk about a little bit today. And then all of that is going to build us up to the next topic, the next subject matter, which is the science of chemical reactions and equations and how we balance equations and how we can use molar mass and some other things that we've already talked about to predict how much product a reaction will generate. So that's the next subject. That's for down the road a little bit. For today, we're just going to review. Remember that what we said in the last video was that when you look at a chemical formula, every capital letter represents a different element. So how many elements are there in this compound? Well, let's take a look. You have a capital letter followed by a lowercase letter here, so I'm going to separate that. Then you have another capital letter here. So we have a total of 1, 2, 3 elements: sodium, oxygen, and hydrogen. And 3 atoms, because there's no subscripts, which means there's only 1 atom of each type. Now remember, if there is a subscript in the formula, it multiplies the element immediately to its left, so the one that came just before it, but only that element. So how many atoms are in this compound, calcium nitrate? Well, again, we'll use the lines. We'll draw lines. There's a capital lowercase letter, then there's a capital letter, then there's another capital letter. So there's 3 elements. Right? There's calcium, there's nitrogen, and there's oxygen. But the oxygen has a subscript number 3. So there's 1 calcium because it has no subscript. There's 1 nitrogen because it has no subscript. And then there are actually 3 oxygens. Okay, so the 3 gets multiplied times the oxygen, but not anything else. Okay, the subscript only is attached to the element immediately before it, immediately to the left. So there's a total of 5 atoms. There's 1 calcium, 1 nitrogen, and 3 oxygens. Then when you have parentheses, that changes the effect of the subscript, and the parentheses creates a group, and the number next to the parentheses affects everything in that group, but nothing outside the parentheses. So let's take a look. How many atoms of each element are there in this formula? Okay, well, we got to start by finding out what the different elements are. There's aluminum, sulfur, and then oxygen. So the first one is the easiest one. There's a little 2 next to the aluminum, so that means there's 2 aluminums. And then the parentheses, inside the parentheses, there's sulfur and the oxygen in the parentheses has a little 3 next to it, which would mean there's 3 oxygen. However, the fact that there's a 3 outside the parentheses means it multiplies times everything that's in the parentheses. So it distributes just like it would in a math problem. So there's 3 times the sulfur, because there's 1 sulfur in the parentheses and then 3 times. And then the oxygen is actually 3 in the parentheses and then times 3. So there's actually 9 oxygen in this formula. So 2 aluminum because of the 2 subscript here. 3 sulfurs because the 3 outside the parentheses multiplies times the sulfur. And then 3 times 3 oxygen means 9 oxygen. Okay, so let's go back and review just really quickly, what is a mole? Okay, a mole is just a name that we give a group of things just like a dozen means 12. And it could be anything. A dozen donuts, a dozen eggs, dozen cars, dozen kids. It just, when we say dozen, we know that means 12. So a mole of things is this really crazy big number, 6.02 times 10 to the 23rd. And in this case, it could be anything, right? You could have a mole of donuts or eggs or anything like that. But typically when we're talking about things on this scale, we're talking about atoms and molecules. So a mole of atoms or a mole of molecules or a mole of ions, okay, those are the things we're really working with when we talk about the mole. And what the mole does is it gives us a way to group atoms and molecules into bundles, and then we can compare the bundles to each other. Right? Because if we know there's the same number of things in each bundle, we can then compare the bundles to each other. So when we're talking about molar mass, we're talking about the mass of a mole of things. So when you look at the periodic table, every element on the periodic table has a number that goes with it. So in this case, carbon, it's kind of small down here, but the number for average atomic mass is 12.001. We usually just say 12. Okay, 12 atomic mass units, or AMU. That's the mass of a single atom of carbon, which by itself isn't really helpful because we never work with single atoms of anything. They're just too small. It's possible, but it's really, really hard and not, generally speaking, very helpful. And it's nothing we would ever do in our class. So we deal with things that we can kind of work with and see and touch and that sort of thing. So on that scale, we're talking about a massive, massive number of atoms or molecules. And so what we do is we say that the number for the atomic mass is the number of grams that 1 mole of those atoms or molecules would weigh. So in the case of carbon, the atomic mass is 12 AMU. But the molar mass, so the amount of grams that 1 mole of carbon atoms would weigh, is 12 grams. So we take the same number and we put the unit grams with it. So that means that 6.02 times 10 to the 23rd carbon atoms, which is a mole of carbon atoms, has a mass of 12 grams. Or, do it the other way, and you can say that if you weigh out exactly 12 grams of carbon, you would have exactly 6.02 times 10 to the 23rd carbon atoms. Okay, so when we want to find the molar mass of an element, that's really easy. We just saw it. We look it up on the periodic table. It's got a number with it. That number is usually a decimal, but you can most of the times round it to a whole number. And that's it. That's the mass of the element. And you put grams with it, and that's the molar mass. When you want to find the molar mass of a compound, which is made up of groups of atoms and groups of usually different elements, or a compound is always elements, different elements, all you have to do is look up the mass of each element that's in the compound and then add them all together. So, for example, if we look at sodium chloride, okay, remember that's sodium and chlorine, there's 2 capital letters, 2 different elements. If you look up sodium on the periodic table, it has a mass of 23 grams per mole. Okay, it's 22.999 something, but we call it 23. Chlorine is a little bit trickier because its mass is not a nice, easy, round number. It's close to 35.5. If you said 35.5, I wouldn't mark that wrong, but rounding it one way or the other kind of changes the dynamic a little bit. So, in order to find the mass of the compound, well, we just add those two together, and we see that the mass of sodium chloride is 58.45 grams per mole. Okay, so what is the mass of calcium sulfate? Remember, you look up the elements. This one has a subscript in it, so be careful with that. And then you want to add all those masses together to find the mass of the compound. Let's take a look. Calcium, sulfur, oxygen 3 times. So if we take a look at the periodic table, you'd find that calcium has a mass of 40. okay, rounded. Sulfur has a mass of 32. These are grams, is the unit, always got to have a unit. Oxygen has a mass of 16, but because of this little 3, we multiply that times 3, which is 48. So then if you add those together, 40 plus 32 plus 48 is 120 grams, and that's per mole. Okay, so here we go. Find the mass of aluminum sulfate. You might see a pattern here. These are the same ones that we counted the atoms of at the beginning. So here's aluminum, sulfur, oxygen. Aluminum has a mass of 27, has a subscript, so we multiply that by 2. Sulfur has a mass of 32. Because of the parentheses and the subscript there, I multiply this by 3, which is 96. Oxygen, finally, right, has a 4, and that's times the 3, so that's 12. Okay, right, because it's 16 times 4 in the parentheses, and then times 3 outside the parentheses, which is 192. So now to add all that together, the total for the whole compound is 342 grams per mole. Okay, here's a few for you to try. Find the molar mass of magnesium fluoride, MgF2. So you take magnesium, which is 24.3, plus fluorine, which is, we'll round that to 19, but that's times 2. So 24.3 plus 38 is 62.3 grams. What is the molar mass of sodium sulfate, Na2S? Okay, sodium is 23. Because of the subscript, that's times 2, so that equals 46, plus sulfur, which has a mass of 32, means the mass of the compound is 78 grams per mole. Okay, calcium hydroxide, CaOH2. What's the molar mass? Okay, calcium, right? We've got calcium, we've got oxygen and hydrogen. Calcium, there's no subscript, so that one's pretty easy. We look up calcium, and it's got a mass of 40. Kind of cover that up there, but there it is, 40. And then oxygen has a mass of 16. It's in the parentheses. There's a 2 on the outside, so that's 16 times 2, which is 32. Plus hydrogen, which is in parentheses, has a mass of 1, times the 2 because of the parentheses, so that's 2. So 40 plus 32 plus 2 is 74 grams per mole. Okay, last one. Calcium phosphate, Ca3PO4, 2. So let's break this down and find the molar mass. Okay, so again we're going to start with calcium. Has a mass of 40 times 3. So that's 120. Then phosphorus, which has a mass of 31, it's in parentheses with a 2. So 31, let's clean that up a little bit. There you go. 31 times 2 is 62. And then oxygen is 16, times 4, because there's a 4 in the parentheses, and then times 2, because of the 2 on the outside. So 16 times 4 is 64, times 2 is 128. So if we add all that together, we have 182 plus 128, which, if my calculations are correct, comes out to 310 grams per mole. Okay, so that's how you do this. We look up each element, find its molar mass, multiply by any subscripts that are in the formula, and then if there are parentheses, you multiply also everything in the parentheses times the number outside the parentheses, and then you add all those numbers together to find the molar mass of the compound. So again, in the next lesson, we're going to be taking a look at converting between grams, which is what we've done, the molar mass, and moles. So again, the mole is just a bundle of atoms or molecules, and when we get into chemical equations and chemical reactions, you'll see that being able to convert between grams and moles is going to then enable us or allow us to convert between a certain amount of starting material in a reaction and a certain amount of final product at the end of the reaction. You can't do it directly from grams to grams. You have to go from grams to moles, and then moles to moles, and then moles to grams, which sounds really complicated, but honestly, it's nothing we haven't done already. It's just putting a couple of things together that we've reviewed some of now, and we'll review the rest tomorrow, and then we'll be able to move on toward chemical reactions and equations, and how to balance those, and how to make predictions about what's going to come out at the end of a chemical reaction. So we'll see you next time.